Hey everybody, and I'm looking at everybody because there's no one here in the classroom tonight, and that's okay. This was optional in-personal attendance, and they were saying it's supposed to snow tonight. It's Happy Valentine's Day. I don't want to get stranded downtown. Who knows who I'll be spending the night with? Thanks. So anyway, that's okay. I'm keeping an eye on the weather here. If it starts getting snowy or whatever, I'm going to bolt. But it's all right. And it is really cold right now. Yeah, it's. I walked over here and I'm like, yeah, I think my lightweight shirt and just my rain jacket was not the best choice of attire tonight. But you know what? We'll get through. It's nice and toasty here in the classroom. So I hope you're all warm at home wherever you are. So let's see here. We got some exciting stuff tonight. So this is week 6, and we are officially into the second half of the course. And the second half of the course, I think it's fair to say things ramp up a little bit. We're getting into the more advanced topics in the course, and especially the final 2 projects. We'll be seeing Project 5 tonight. And in Project 5, we start over with a brand new Maven project. And we build a client-server application that uses a REST API to communicate between a Java command line program, which you're all used to working with by now, and something new, a Java web application that provides the implementation of the REST API. So the sort of the lecture part, the demonstration part of tonight's class will be all about that. And then we will have our third and final pair programming activity, which is which you'll have the option of doing remotely, because remote pair programming is a legitimate way to pair program. Although I wanted you to have the in-person experience first, so you can sort of understand the mechanics of it, because there are some challenges when you're remote. And I'm really curious for the people that choose to participate in it, what their experience is like, and how it then compares with the in-person pairing that we've done. So we will talk about Project 5. We will do our last pair programming activity. But first, I want to open up the floor for Prime Minister's questions. So this week's assignment that was due was the Java cones. I'm curious to hear about your experiences with that. And then also, we've got a couple projects in the hopper. Right? We've got Project 3, which is due next week. And then also hot in the heels of that is Project 4. So a lot going on, as always. What can I tell you? What questions do you have? What would you like me to know? What are some of the things that you're still interested in or curious about? Please feel free to come off the mic or post something in chat. Yeah. There's another student. Okay. We will let the other student join, and I'll give them an opportunity to ask any questions they might have. Hey, if you're just joining us, we're doing Prime Minister's questions. So far, no one's had any questions, and we've got lots of other stuff to cover, but I wanted to give anybody who's just joining an opportunity to ask any questions about the Cones project that was due tonight, Project 3 or Project 4. Nope. Wait, there we go. Okay. Oh, question. Out of curiosity, what would an invalid file look like in terms of parsing dumping? Wait, Cameron, do you mean what the structure of the file? And you're talking about a text file or an XML file? Text file. Okay. Well, let's see here. In Project 2, when I graded it, I tried my best to create an invalid file. So as you'll recall, or you may recall, there were a couple of test cases around that. The first one was, okay. So then, right, okay. So I think what an invalid file looks like. Oh, it doesn't have a valid date or whatever. And really the behavior that I was looking for was when your program encounters an invalid file, does it detect it, and does it provide a nice error message? So for instance, I don't remember what your particular case was. But for instance, if I gave a kind of bogus input, just like a bunch of random characters and stuff, if it threw something like an array of index out of bounds exception, or if it said it can't parse data or something like that, and threw an exception, that's not what I expected. I expected it to be caught and have have a nice error message, ranging from it could not parse text file to hey, on line 23, I saw this problem. Another test case that I had is I generated the text file with one invocation of your program, and then I replaced the year 2024 with 4 X's to see if the text file validated the dates on the way in, right? Because you can't necessarily trust that your file hasn't been corrupted somehow, or that the bad guys haven't broken in and then changed a bunch of information in your file. And I was just curious to see how people's projects detected that, and some people did, and some people didn't. And now you learn, and so then you might see some of those same test cases with Project 3. Cool. So thanks for the call out on the usefulness of the cones. I'm glad you found it to be a valuable, well, or at least a useful exercise. That's the intent, right? Because there's a lot to the Java language, and I think it's new to most of you, or it's been a while, since you really worked with it. And my hope with the cones was that it gives you the sort of the fundamental building blocks of the language syntax and some of the core APIs, in addition to the lectures, right? Some people learn really well by watching the lectures or going through the notes or doing their own research or things like that. And then other people learn best by applying, and if nothing else, I think the application of it in the cones will reinforce what's learned in the lecture. So again, I'm glad you found that to be useful. I know it's a lot of work, but I think most of that stuff you'll end up using in your projects. Get someone else joining. Yes. So if you're just joining, we're finishing up Prime Minister's questions. We talked a little bit about how programs should respond to invalid text files, and noted that the cones were useful. If you just joined, are there any specific topics that you'd like me to discuss before we dive into the main content? Okay. If not, then let's go. Okay, so so far in the course, you have I've introduced 4 projects, right? We are building up an appointment book application, and project 1 was working with the command line and some very simple classes, and you got to learn about like collections API a little bit, and you got to do command line parsing. Project 2, you learned about file I/O by writing the appointment book out to a text file and reading it back in. Project 3, which hopefully is in progress, or it will be started very shortly, next week. You learned how to sort objects, and you learned how to format dates and times using those standard java.time classes. In Project 4, you worked with XML, and so you get to represent your appointment book in a different format using a completely different API to generate the external format and then read it back in. Project 5 continues that by adding a REST API for your appointment book. And well, if we're in class, I'd ask for a show of hands, but I'm guessing that some of you might have at least heard of what a REST API is, and I hope that you watch. Actually, please do watch. It's pretty important to watch the lecture about web applications. I think hey, everybody's used the web, right? But I think some of the details about how HTTP works, about how Java servlets and the Jetty container and all that kind of stuff, that's probably new to you. And even some of those concepts might be new. So while I'll talk a little bit about those things in the context of Project 5 tonight, please do go back and review that lecture. And actually, the lecture on mocking with or testing with mock objects is also really essential for this content too. We'll see. I'll discuss it tonight. We'll see how that Mockito API can be used to write tests for your servlet code for basically your web the code that handles the web request that implements your REST API. How tests can be written for that without having to, that are true unit tests, so you don't need to run the whole web application as you're developing your code. So lots of great stuff tonight. There'll be a pretty deep dive. We'll probably spend an hour and a half or so talking about this. We'll take a break. Don't worry, I'll get tired. And then we'll do our third and final pair programming after that. So a RESTful web service for your appointment book. So far we've just been dealing with the command line, and we'll still deal with the command line in this project. So just to be clear, we're not writing a web page. What we're doing is we are writing a web application that serves up certain content. And so then, because it's a web application, it uses HTTP, and we have the communication between the client and server structured using the REST structure, the REST patterns that make up a REST application. So what I'm going to do first is walk through sort of the expectations of the project. Then we're going to create our new Maven project and our new code base. And we're going to talk about all the pieces parts here, because there's a lot more to this project than there were the first couple. So after we create our new project, there will be a class called Appointment Book Servlet. Now, a servlet is a Java object that runs inside a web container that responds to REST API. Well, it responds to web requests, HTTP requests. And as you can learn about in the lecture, there are a number of what are called verbs for HTTP. This is the get and the post and the put and the delete and and head and other things like that. And then the servlet is the code that is invoked when one of those URLs is requested from the servlet, and then it is up to that code to formulate a response to that request. So that's what a servlet is. And so the servlet is really the thing that provides a REST API over your appointment book. Because in this class, you're still using your appointment book and your appointments, right? That code that you wrote in week 1, you are still using here in project 5. And the project that's created, the Maven project that's created, will create a web application that, when deployed to a JD web container, it has a name of apps book, appointment book. And so that means when you hit URLs, when you fetch or request the following URLs, you have the following behavior. So a URL, is on a host and a port, and we'll see examples of this shortly. And when you say HTTP host:/port /appointment book /appointments with a given owner name, if you make a request, you make an HTTP GET request, then it should return all the appointments in the appointment book formatted using your text dumper. So, we want text dumper, we want XML dumper. I might change my mind. I might make that XML dumper, I'm not sure. Anyway, the whole idea here is that when you hit that URL with a GET, then it takes the appointment book for the owner with a given name and returns it as text using the text dumper. So this is interesting. We're using the text dumper not to dump to a file. Instead, we're using it to convert an appointment book to in text format and send it as a response to the HTTP request. If you send an HTTP post request to that same URL, that will create a new appointment in the appointment book with a given name. And the request parameters should have all the information that you need to know about the appointment. So it has the owner and then the description, begin and end time for the appointment. Just like when you're creating on the command line, if the appointment book doesn't exist, it should create a new one. There's also some new functionality that's here in Project 5. And that is the ability to return all appointments between a certain begin and end time. Actually, well, that begin between a start and an end time. Note that in all these URLs where you have a date like begin and end, it's the same format as it is on the command line. So it's let's see here now, it's 5 strings, right? It is the date, I'm sorry, it's 4 strings. It's the date, it's the time, it's the AM, PM, and the time zone. So it's those 4 strings all get put on the URL and sent to the REST API. So here again, when you perform an HTTP GET on this particular URL, and you have the name of the owner, and you have the begin date time and the end date time. Sorry, that's cut off. Then it queries the appointment book and returns the appointments between those 2 dates, that begin between those 2 dates. There's another important thing to note is that because you pass in the name of the owner here, the application, the web application, supports multiple appointment books. So where we were very clear that with the text file, for instance, you can only have 1 appointment book per text file. Here, this application supports multiple appointment books. So this is the REST API. This is the server side of it. There's also a client side. Well, I mean, it is a web server, so you can hit it with a web browser, but that'd be slow for me to have to test. I, of course, want something fast to test because I'm lazy. And so there's also a command line program that interacts with your server by sending HTTP requests. And so note that again, the command line looks pretty familiar. There's some different things here. However, dates and times are still in the AM, PM with a time zone, not 24-hour. So let's take a look at the command line. It's got, is it spread over? Spread over 2 pages. That's kind of lame. I should fix that. Basically, it has the args that we expect. Owner, description, begin time, and end time. However, there's also some options. So you can specify the host and the port, and you can also do the search from the command line. And actually, when you specify search, the only required arguments are owner, begin, and end. You don't need a description there. So then, right, so if you try to do a search and provide a description, it should fail. And when you perform the search, what the client should print is the pre-printed version of the appointments that were returned there. And so then and this should be, the pretty printer that you created in your project 3 is now used in your client to pretty print the data that comes back as text or as XML, depending on mind, to standard out. And so that's what the -search does. And then you've got -print and -readme, which have the same semantics as they have in previous assignments. So here are some examples of that command line. I noticed that host and port are both mutually required. So if I want to add an appointment to the server, so assuming my server is running, is running on localhost and port on localhost and port 8080. When I provide the arguments Dave and then teach Java class with these dates and stuff, that will add a new appointment to the server. Here we search for appointments that begin between 2 times. And this will basically pre-print all the appointments in the month of November because we have host and port, and we have -search. You put in the name of the owner, and then the 2 times that you queried between. And if you want to pre-print all the appointments in the appointment book, well, you just say -search with just the name of the owner. And I think those are, those are pretty much the fundamental use cases for the command line tool. And of course, error handling, you want it to be graceful. You want to have good error messages, and there are, this is a much more complex application. There are more error handling. There's more error messages, more errors that could occur. So, for instance, you can have a problem on the command line syntax. The format of the day or time is not correct. You can't get to the server because it's not running. Or that, hey, you've got something, you've got bad data which is passed to the URL, or rather, your servlet receives poorly formed data. Okay, I want to pause here for questions because there was a lot of content just now, and we'll see we'll see the application and how it's structured and how to get started with it shortly. But in terms of requirements, are there any initial questions? Okay. Cool. Thanks for weighing in. Okay. Oh wait, there was one. No, it's doing stuff. Yeah. Time zone is required. Yes. Yeah, and that's a requirement starting in project 3. That time zone is required for both the start and the end at times. And it's required because, well, appointments are probably in the same time zone, but there's another variation which is flights that can be in different time zones. But yeah. Yep, time zone is required. Okay, so now you're probably wondering, like, how do I write all this code? How is this going to work? And you're not the first students to wonder that. And so then to get us started, you create a new Maven project, which is all configured to be a Java web application, and it gives you the beginnings of all the pieces parts, like the servlet of the command line tool, of the tests, because you'll be writing tests for all of this. There's still the code coverage requirement for Project 5. And so then the skeleton will hopefully get you off the ground and give you a place where you can then evolve the program to go from this simple dictionary application, which comes out of the box, to your appointment form. So I will create that now. So if you go to, and feel free to play along at home, if you go to if you go to the checkout of your code, you'll see that there is a create REST API, create REST project shell script. Oh yeah, this needs to be run on the PSU machine, doesn't it? So I will do that. Java winter 2024. Create REST project. And so now this is creating a new Maven project called appbook-web. So now if I do a git status, we'll see that my POM, a top level POM, was modified, as was my appbook-web. And I'm just going to go in there and make sure that I can run it. So I'll say Maven w clean verify, clean just do verify. So same Maven commands to build the project anyway. We'll be seeing how we can use Maven to run Jetty here shortly. But I do the clean verify. Now, there's a big difference between this Maven project and your the Maven project you've been working with so far in your first 4 projects. And that is, this Maven project creates a web application. And not only does it create it, but it also, when it runs its integration tests, it actually starts the web container, it starts Jetty, and then runs integration tests, what I would say are true integration tests against that. And so the REST API is actually being used inside a web application as part of the integration tests. And that gives you, a lot more power to actually test your program for real, as opposed to just what the unit tests provide. But everything was successful. This is good. So now I'm going to go ahead and check this in. Git commit, and I'm going to say added REST project. And let's see here. I want my pom.xml and I want my web. Oh, I want to add it. Sorry. Fine. Oh, wait, since it git commit -a, does that work? Okay, fine. Git add app web commit without the nice, cool. All that's there. So I think I'm done here. Oh, but you know what? I will point out, just sort of glancing at this, there are some there are some files that should seem familiar, like there's a POM, and look there, there are integration tests, you've got your main code, you've got your unit tests right here, but you've also got some new stuff. You've got this this web app web.xml file, which you shouldn't need to change, but if you watch the lecture, you know what that's all about. And there's also this index.html, which we will be looking at. So out of the box, that little sample dictionary program does come with an HTML file that has a couple of HTML forms that you can use to interact with the application. I'll reiterate this again later, but this is just if you are an old school HTML person and you want to interact with a web application using an HTML form, great, you can do it that way. It's not a required part of the project at all. As soon as you start changing your application, you'll need to update the HTML file also if you want to keep using it. If you don't want to do that, that's fine. But it is an easy way to interact with your application, with your web application. Okay, so I'll get off the PSU machine, and now I will do git pull. See those latest changes. I didn't do a git push. Git push. There we go. Pull over here. Good. Now I've got my stuff. Now I'm going to go to IntelliJ where I'm a little bit more comfortable. IntelliJ. And I will synchronize or reload everything from disk. And this should get let's see here. Yep, it's a new appointment book web. It is syncing my POM files and everything. And good as bold, it has detected this new web application. Okay, cool. And as I said, there's a whole bunch of files in here. And well, we'll take a look at those later. I think I'll go back to the assignment at the moment. Okay, so we've got well, actually, let me just run the test just to make sure that everything is okay, that everything builds all right. So let's run these tests. It's building the project. Looks like it's okay. So the tests were happy. Let's also run the integration tests. The unit tests were happy. Let's also run the integration tests. Oops. Oh yeah, it failed because the server wasn't running. Well, that makes sense. It's okay. Okay, now I'm going to go play with this application outside of IntelliJ, so we can better understand the pieces parts. Okay, we'll come back to all that stuff in a bit. So here is my visual depiction of how this application works. Like I said, there are two parts to this. As a matter of fact, there are two programs that you run. So, up until now, and certainly in this class, and probably in many of your other classes too, when you run one program, it's been literally one program, right? You build it, you compile it, or you run the Python interpreter or whatever, and it starts at the main method, the beginning of the main method, it goes and executes all your code, and then exits. That's what it does, right? And that's cool, and you can do all sorts of great stuff with that. Here, however, we have distributed programming. We have two processes, two programs that are talking to each other using REST, using HTTP. And so on the right is the web server. And the web server, you start up and you just leave it running. Sorry, web container is probably a more technical term, but you know, it is a web server. Right, so it just sits there and it starts up, and once it starts up, it's just waiting for someone to talk to it. Right, it's not doing much of anything else. But if you look inside that, what you have is on the outside you have the Jetty web container. So when we run this thing, we use Maven to run it because it puts all the right stuff on the class path. It'll build the project and deploy it to a web container that it starts up. And then inside that is something called a web application. It's a .war file that represents, well, the entire appointment book application. And one of the things inside that is your appointment book servlet. And so then when the web container receives a request, like an HTTP GET for, you know, the appointment book / appointments !owner equals Dave URL, because the process is listening on port 8080, it receives that request. And what it does is it basically translates the resource that's being requested to a servlet. And if it can't find it, it returns like a 404 or something. But here what it does is it says, aha, it looks in the appointment book web application for the appointment servlet. And then ultimately it says, oh, I'm handling a HTTP GET that's going to call the doGet method on your servlet. And we'll see all that stuff later. Now, the thing that makes this request can be, well, anything that makes an HTTP request. It can be a browser, it can be an app, it can be, you know, whatever. In this case, what it is your Project 5 command line program. This is another Java program that starts up, and it uses a class called Appointment Book REST Client, which comes out of the box, to ultimately make the request to the servlet. So this is why this is an interesting project, because what we're dealing with is two programs that are talking with each other, communicating with each other using HTTP. As we'll see, you know, the web container will serve any HTTP request. It doesn't care where it's coming from. So we'll see that it not only can handle requests from the command line program, but it also handles things from the web browser, or, you know, either direct URLs or from an HTML form. So let's take a look at how that's done right now. So I'm going to go back to the command line, and let's see here. Here I am on my local machine. I'm going to want two terminals, actually. So over here, we're going to have Java 1.4. So we're in the same directory, and we're going to run the two parts of this program side by side, or this project side by side. So over on the right, I'm going to try to mirror this picture right here, this graphic right here. So over on the right, we're going to run the web container. And we're going to do that by saying Maven W, and we're going to ask Maven to run the Jetty plugin and the goal of Jetty plugin, yes, of Jetty plugin. And that's what I recommend. Right? There are a couple other ways to run it. What I say? Yeah, maybe Jetty plugin. And when I do this, it builds I'm not in the right directory. Sorry, I should be in the appointment book directory, the appointment book web directory. Run Maven Jetty run over there. And what this is going to do is it'll run the project. So it will compile the code. It will build everything. In particular, it will build the web application, the WAR file, assemble everything, and then looks like it's running. Yep. And then start up a Jetty web container that is running on port 8080. And if I go back here and I hit the URL localhost 8080, well, something's running. I returned a 404 not found, but I said, hey, you can go to the appointment book. Yep, I want to go to the appointment book. And here is what the appointment book web application serves up by default, which is this index.html file that contains a form. We'll take a look at it later. But anyway, this is evidence that the server is running. If I then go and Control-C this and stop this, and then I try to reload the page, it says the site can't be reached. So I'm running it. So over on the right is where we run the web application. Over here on the left, we're going to invoke the command line. So, and we do it the same way that we do our other command lines here, or our other command line programs. So we're going to have appointment book, oops, target. Oh, you know what? I need to go and I need to build the, yeah, I need to go and build the jar file. I can do that with package, or I just do a Maven verify, and that would build it also. I'm just going to go package it, however. That'll be the fastest way to get there. Because I think package will work. Go get my jar file. Target appointment book client.jar. Yes. So java.jar target appointment book client dot jar. And when I run this, it gives me an error message saying missing command line arguments, because it's true. This main method requires 4 parameters: the host, the port, and then a word and a definition. So actually, let me talk about what the it doesn't really. Okay, well, so the way what this application does is out of the box, it maintains a dictionary of words, or I guess key value pairs. And so you can do things like create a new word definition pair. So you can say doe, deer, female deer. Apparently it still remembers the references from last time. And I can click submit here. And what this does is it then communicates with the server and creates a pairing doe, a deer, a female deer. I can go back to the web browser. And now I can list all of the word definition pairs, and it gives us doe, a deer, a female deer. This is all coming from the servlet. And now I can, on the command line, do similar things. So I can say, to communicate with the machine, the web application running on localhost port 8080. And if I want the definition of the word doe, it then returns doe, a deer, a female deer. Because what it does is it makes the same web request to the server as I did here in my browser. So, I can say, ray a drop of the golden sun, like this. And now if I go back over here and I list all of the word definition pairs, I see doe and ray. So that's what this application does out of the box, right? You've got a web application that runs over here in the right. It provides certain behaviors, like by creating dictionary entries and for printing them out. And while you can access that through the web browser, you can also access it through the command line client right here. So yeah, if I just again here, I can get all of the entries by just providing the localhost port. So this is what you get out of the box, and really, what this assignment is all about is starting with this application and understanding enough of it so that you can then evolve it into an appointment book application. So instead of having this behavior here on the command line, it has the behavior as described in the assignment. So I want to pause for questions again. So now you've seen the expectations of the assignment, and you've seen from the outside how the project can work. Before we start diving into code, what questions can I answer for you? Yeah. Okay. Sure, yeah, and we can definitely talk about some stuff next week. Okay. So this is, let me take a quick, let's now start looking at the code and talking about like how all of this works. I mentioned some pieces parts here in the assignment. Things like the appointment book servlet and the appointment book REST client. So let's look at some of that stuff. Let's look at the appointment book REST client. So that's in the main code base, Java, appointment book servlet. Okay, so oops, there we go. Okay, so appointment book servlet extends HTTP servlet. Now, HTTP servlet is a class it's a Java class. Well, it's a class from, well, okay, servlets. As you learned about in the lecture, servlets are a standard API for handling web responses. HTTP servlet is a standard API for providing, well, for handling HTTP requests and then providing the response. Because the whole idea here is that the application server, so the web container. So Jetty is this open source project that provides an implementation of the standard API for writing Java applications. It defines interfaces between the container and your application. And so what you do is you provide an implementation of an interface that it knows about, like HTTP servlet, and it will detect that, and it'll make it so that you can, it'll route these URLs that come in to your particular web application. So to your particular servlet. So ultimately, it's this thing that receives the requests. And what it consists of is, again, this is really easy to get you off the ground and everything like that. It's got a dictionary, which is a map of strings. So these are your key value pairs. And let's walk through some of this. As a matter of fact, though, let's do something more interesting than walking. Let's debug some of this. So, debugging is an important part of software development. And actually, do I have the debug stuff here? I do not. Okay, that's cool. So now let's take a look at debugging our server. And what we'll do is set a breakpoint and then walk through the code so we can learn what it does. We can look at the parameters that are passed in, all that kind of good stuff. So I think some of you have some experience debugging in IntelliJ, but I want to, I'll go through this stuff anyway for anybody that maybe hasn't debugged in the same fashion. So the whole idea with a debugger is that you run a Java program with some certain command line options, and that allows another process, which is the debugger, to attach to it. And then there's a communication protocol back and forth in which the Java virtual machine does things like, oh, hey, you wanted to be alert, hey, debugger, you said you were interested in in debugging a certain line of code. Well, I just hit that line of code, and then the debugger is able to visualize the state of the virtual machine at that particular line is executing, and then you can interact with the VM at human speed instead of computer speed. So the first thing you need to do is tell your Java virtual machine that you want it to be debuggable. And the way you do that is by creating what's called a new run configuration, a new debug configuration in IntelliJ. And the new type of configuration is remote JVM debug. So I'm going to call this one localhost, and I'm going to debug it on port 5005. This port is different from the HTTP port that the server runs, right? This is the Java debug port. This is not the HTTP port. And we want to say yes, attached to a remote JVM, localhost port 5005. That's sort of the default here. And it gives you this big long argument, a list of arguments to add your command line. So it's really easy to copy that to the clipboard. Let's see here. I'll create this configuration, and there's a here that changes to localhost 5005. Now I need to tell my Java virtual machine to listen for debugger connections on that port. And ultimately what I need to do is to set that option on the command line of the Java virtual machine. When you're running from Maven, like we're using Maven to run Jetty, the way we do that is by setting an environment variable called Maven ops, and there, and actually to that value. We've got a context switch here because if you're wondering how to, if you're wondering about more details here, they can be found on the Getting Started repository, which is in your README. There is a, there we go, here is a section here on how can I use a debugger to debug the, to work with projects. And so I have a better explanation here. I'll post this in the Slack. And of course, there's tons of good online resources about this also. Java programs at. So again, you need to talk about, yeah. So if you want to debug something in Maven, like when we run Jetty, it uses Maven ops. Okay, so I've executed that there, and now I'm going to run Jetty again. And the first thing you'll go by here, you see that it says it's going to listen on that port 5005 for a debugger to connect. So now it's all up and running. I'll go back to IntelliJ, and now I'm ready to attach to that Java virtual machine. I'm going to click the debug icon. It's a picture of a bug, not surprisingly. And it says it's successfully connected. So right now, you've got the Java virtual machine that is running your web application. So again, we've got this thing over here on the right, the Jetty web container, which is running your servlet, ultimately. And it is sitting there waiting for a couple of things. It's waiting, well, actually, sorry, it's waiting for an HTTP request, and the debugger is already attached to it saying, hey, when you encounter some code that I care about, please tell me about it, and we can start debugging. And so I set a breakpoint for this line 35 by clicking over here in the margin, and that sets a breakpoint. And here in the doGet method, so I'm going to perform an operation now that, well, the first thing I'm going to do, the first I'm going to, what do I want to do next? I want to populate some data in the appointment book. So right now, I reloaded the page. Sorry. That was dumb. Right now, I'm going to go back to my appointment book. I'm going to create a couple of doe, a deer, and then a lunch, and then play, a full sun. Great. So now I populated a couple of things in there. And now I'm going to, and both of those were created with HTTP post. And we'll talk about that in a little bit. Now what I want to do is I want to list the definition of a word. I want to list the definition of the word doe. And so I'm going to put that in here. I'm going to click submit. This will do an HTTP GET to the appointments URL and pass in the value of doe for the word parameter. So here I am in my Java code, and I'm debugging it. So because it's highlighted in blue, it means that the JVM to which the debugger is attached is currently executing this line of code. And down here at the bottom, it tells me all sorts of things. It tells me the call stack of this. So notice that my code here in in my package is called by stuff in JavaX Servlet, and if you go up here, there's this Jetty stuff on the call stack also, and all sorts of things that you don't care about. But this is the whole idea: is that you are running your code inside this container, and the container is ultimately the thing that receives the request, and it has successfully routed that request off to your appointment book servlet. And because it was an HTTP GET request, it is calling the doGet method. So here we are in the doGet method. Now doGet takes two parameters. The first is an HTTP servlet request, which is an object that represents the request that is sent in from the HTTP client. And then there's also another object, which is called HTTP servlet response, or is an instance of HTTP servlet response, which represents the payload that will ultimately be returned to the client. And so what the doGet method does ultimately is it interrogates the request object, performs some application logic, and then populates the response object accordingly. So this is a really interesting abstraction that the web container provides, right? So as long as you provide something that implements the doGet method to do what you want, you can interact with any Java web container that conforms to this API, right? By programming to the interface. Object-oriented programming, it's what it's all about. So what do we do in our doGet method? Well, we do the following. The first thing we do is we set the content type for the response. So I don't know how familiar you are with like MIME types and data encoding and all this kind of stuff, but the bottom line is that because HTTP is a text-based protocol, any content that you send back needs to be in some form of text. Or something that's encoded as text. So even like when you fetch, when you go to a web page and there's an image there, that image is sent over the wire as text, as an encoding of the image as text. In this application, we're just dealing with text. So all of the content type is going to be text plain, or text XML if I decide XML. I didn't decide yet, but anyway. So the first thing we do is say, listen, the response that I'm going to return is going to be of type text plain. Okay, now that's what it's doing right now. In the debugger, I'm going to use the step over function to go to the next line of code. And now the next line of code is highlighted. So what I'm going to do is I'm going to ask the request object for the parameter with the name word. And actually, one of the things that maybe I should have, I don't know if this is going to make sense to most people, but if we go and look at the source to this page, it's plain old, 1996 style HTML. And here is the second form. That's the one that we submitted. And it has an input, which is that button. And the name of the input is word, which means that when the form is submitted, it will send the word parameter to along with the request with the value that's in the input box. I don't necessarily expect you to understand it. It's pretty straightforward, though, especially if you've done anything with HTML before. I'm going to call this getParameter method, which is a method inside this, this class. And so let's step into that method to see what it does. So now here I am inside the getParameter method. And getParameter takes in the name of a parameter, and it's going to get its value from the request. And it's going to do some special handling. If the value of the parameter is null, or if it's empty, it's going to return null. That way, if someone passes an empty string, it's the same as null. Otherwise, it's going to return the value of that parameter as obtained from the request. So now when we step through this code, we see that value here is do, right? That's what I put into the web form, and that's ultimately what gets sent to my Java code, to my servlet. And we can also see it over here in the debugger. And actually, we can also learn about the Java, the HTTP servlet request object. And so you can expand this and see all sorts of information that really doesn't make too much sense. But it does tell you things like, oh, it is an HTTP get method. It is for the appointments context. And I think also in here you can get like the full URL. Well, maybe not so easily here, but what you can do is you can, if you highlight this and then right click and say evaluate expression, now you can call methods on the request to find out all sorts of information about it. So you can get what is the HTTP method of it? Oh, it's get. What is the, what else we got? Like URL, got request URL in here. And this is the big old thing that I sent in. Also, what is it called? The servlet path, the path info. What's the path translated? Okay, no. Anyway, If you haven't used the debugger before, they are super powerful, and I think pretty much everybody's seen like a command line debugger, like GDB or whatever is used, which is great and is awesome in some environments when you don't have a nice tool like IntelliJ. But when you do have a nice tool like IntelliJ, you can get a whole bunch of insight into your program at runtime. Second only to unit tests, this is the best way to debug your code. Okay, meanwhile, back over here. We've gotten the value from of that parameter, and oh yeah, and by the way, that value was do, and we'll return that. So I'm using the command function keys here. Okay, so the word that was, we're back in doGet. So the word that was passed in on the URL to the get method was do, just like we expected. That's what we put into that input field. So what are we going to do? Well, we have a word. It is not null. And then we're going to call this right definition. So I'm going to step into the right definition. And what does this do? Well, it writes the definition to the HTTP response. So we have, so this is the logic of this program, right? You get information from the HTTP request, and then you do some stuff to it, then you act on it, and then you return something to the client via the HTTP response. So, what we do, what is the logic here? We look up the word in the dictionary. And so when we do that, but not surprisingly, we get the definition of do, which is a deer, female deer. Great, we've got that. And now we need to convey that back to the client. So we say, okay, so if the definition was null, what we would do is we'd have an error code. We'd actually issue a 404 error code. And the way you would do that is we would say response.set status, and then we pass in, a 404, which is the SC, which is short. What does SC stand for? Servlet code, probably. Right, servlet code or something like that. Not found. Now, our definition is not null. Our definition is a deer, female deer. So when we will not take that branch. We will instead do the following. We want to write to the servlet response, the HTTP servlet response. And so HTTP servlet response has a get writer method, which returns a print writer. So this is a Java IO print writer that we've been using, since project 2 probably, right? So okay, good. The Servlet API uses the standard Java APIs for doing something like writing to a destination. I love this code reuse, right? I don't need to learn a new API just to write to a servlet. I can just use print writer. I've been using print writer forever. It's got print line. One of my favorite methods. Okay. So we get our print writer. Oops, I just stepped into step over. Oh, sorry. I think I'm now lost someplace in executing that print writer. So instead, what I'm going to do is I'm going to say run to cursor. Good. Now I'm back in code that I care about, and I'm interested in. And what am I going to do? Well, I'm going to dump the text representation of my dictionary to that print writer. I have mocked up a little class called TextDumper, which is in the spirit of your text dumper that dumps an airline. That dumps an appointment book. Choose some destination. Here, I wrote a little text dumper that dumps to that formats that code that you see. And I'm just gonna, I don't need to go into the details of that because you all know how to write a text dumper. But I'm going to create a text dumper that will dump to the print writer associated with my HTTP response. And then I'm going to dump to that. It'll write some stuff out there. And that essentially, I don't have to send it back to the client yet. It will buffer it there in somewhere in memory. I don't care. And then what we do is we say, we set the status of the response, right? I mean, we've all worked with web pages before. We've all gotten things like a 404, maybe you see 401s, or you've gotten a 500 at a time when there's like a bug. If you watch the web lecture, you'll see that there's all these classes of error codes associated with HTTP. It's all part of the protocol. It's a very important part of the protocol because it conveys what goes wrong. And so it's very important that in your code you tell the client what the status is. That you say, yep, this status was okay. This is a 200, right? 200 means that everything was hunky-dory. So I successfully wrote the definition for that word to the HTTP response. I did it again. And now, let's see here, where am I on the call stack? I will go back up here. And now I will say run the cursor. Nope, maybe I won't. I guess I'm done. Okay, and so that was the end of my doGet method. So, and if we go back to our web application, trust me on this, now it has loaded and returned that value. Similarly, if my word is unknown, if I put this into the URL and hit return, oops, oh yeah, wait, what? Oh, it didn't, why didn't it stop here at the breakpoint again? It returned to 404 like I expected, but it didn't stop there at the breakpoint. That's surprising, what's going on there? No, submit. Oh, that's funny. Am I no longer attached? It says I'm attached. I'm going to reattach and see if it stops again. How surprising. If I reload here. Okay, now it's so for whatever reason, maybe the debugger got confused. Okay. I'm going, so I hit the URL again with word equals unknown. And I'm here in the debugger. And what we're going to see is that ultimately, as I step into things, it gets the word parameter as unknown. And then if I look in right definition, because the definition is null, well, what does it do? It returns a 404. And I'm just going to continue running. And sure enough, that was what was returned here. It said HTTP error 404 because it couldn't find it, which is like an appropriate thing to do for a resource that can't be found by a web application. So that in a nutshell is how the application works. You've got these two components. You've got the web container that handles the HTTP request. That can come from a browser, or it can come from a command line program, it can come from wherever. And there is this interface of standard APIs between the Jetty web container and your appointment book application that allows the two to interact with each other. So because your appointment book servlet implements HTTP servlet, Jetty knows how to route requests right to your servlet. And what does your servlet do? Well, it handles the requests by getting information about the request, such as the word that was passed in, and then doing application logic, like looking up that word in the dictionary, and then returning the appropriate result. So when it finds a word, it formats it as text and returns it to the client. If it doesn't find it, it returns a 404. Okay, I want to pause for questions. So we saw some more of it. We started to see some code. Saw some pieces, parts. We saw how it was implemented. What do you wonder about? No questions? So I think we got one answer, and that is it is time for a break. Let's take a 10-minute break. Say it take 11 minutes. We'll come back at 6:45, and we'll start looking at how to unit test your servlets. And we'll see how that's done. It's kind of wacky. See you then. Okay, hope everybody had a chance to rest their brain a little bit. So, at the beginning of class, we learned about Project 5. We saw the requirements. We saw, I showed you this diagram like 1,000 times that shows the pieces, parts, and we're diving into what's running inside this Jetty web container. And there's your code in there, but there's all this other stuff around it, which, really, other than understanding this picture, you don't need to work with that much. As long as it works for you, as long as you can get it your code and evolve your code, it'll be fine. So, and one of the ways that we're exploring this code is using the debugger. So we set a debug breakpoint as the doGet method, and then we sent the web container, we sent the web server a get URL, and sure enough, the breakpoint was hit, and then we looked through the code that way, and that's how we understood the code. I want to look at the put post method now and do the same thing. So now post is used when you want to create data. If you go back to the web slides, you learn that that REST leverages the various verbs in the HTTP to perform different kinds of operations. Basically, your get, your post, your put, your delete corresponds to the CRUD, the create, the retrieve, or find, update, and delete. And so in this program, when you have a post, it creates new data in the dictionary. So for instance, we saw it already in action here on the command line when we run it with the arguments localhost 8080 Ray and a drop of golden sun. It defines that accordingly. So now I'm going to do another example. I'm going to do me and name I call myself. I call myself. But now, before I hit return, I'm going to go set a breakpoint in the doPost method. So I want to walk through doPost so we can talk about what post does. Okay, notice that it hasn't returned yet because the command line application is making an HTTP request off to the server, and the server is in the middle of executing it, and then the debugger happened, and the debugger stopped. So here we are in doPost. Just for doGet, the first thing that doPost does is it sets the content type for the response, because the post is going to send back some information also. Now, the post looks for two parameters to the URL, the word that we have, and also the definition. And basically what the command line argument does is it crafts a post URL and sends in the name, me, and the definition, a name I call myself. Because if we go and look at the request, actually, can we see? Well, maybe we can't really see the body of it so well, but we'll walk through the code and we'll see how all of this works. So here we are, and the first thing we're going to do is make sure that the parameters are correct. So we're going to get the parameters, and we're going to get the word parameter, and this is the same get parameter that we use in get, so I'm not going to step into it. The word is me, and it's not null, so that's good. We're going to get the definition, a name I call myself, and notice how IntelliJ tells you the values of certain things, right? So you can very easily figure out what hover over it to get the value, but it also sort of puts it over here in gray to the right of the code that tells you the interesting things about some of these lines. So the definition is not null, which is good. And so then what does it do? It actually does some application stuff. It puts the word and the definition into the dictionary. And then, it's going to write back this message, which is formatted as defined word as defined. It writes that back to the print writer. So there is a little bit of content that's sent back, which basically provides some context to the client about what happened. And then but again, it gets the print writer from the response. and it flushes that, which is a good idea. And then it says, yep, I handled it okay. Error code, or return code, status code, 200. Everybody's happy. And we'll go from there. That is the end of the method. Yeah, that is the end of the method. So I will just continue executing. So all of this returns. And then back on my command line, yep, it actually prints out that defined me a name, me as a name I call myself. That is the text returned by defined word as. Because actually, if you go and look at it, yep, basically what we do is we say, hey, define the word. So %s here is replaced with word. This other %s is replaced with definition. And sure enough, what is printed out is the define me as a name I call myself. So now we're using the command line to interact with the servlet. But you know what? The servlet doesn't care. It doesn't care what the client is. As long as it speaks good HTTP, it'll talk to anybody. So that's how the get and the post method work. Now, there's some complexity here. There's some things that are unusual. Like, getting the parameter stuff. Really the logic here, again, super simple, right? We're putting and getting stuff from a dictionary. How might you test this? Well, certainly we're interacting with it now. We're using the browser, we're using the command line. But the browser and the command line are pretty heavyweight, right? It requires that servers running. It's not a fast operation by any means. I would like to be able to write a unit test for this. But how do I write a unit test with code that's meant to run inside one of these containers? And the vast majority of what it does is interact with these objects like requests and responses. Now, on the one hand, this is just Java code at the end of the day, right? There's really nothing very special about this. It's just got some fancy APIs that it interacts with. And the fancy APIs are great when it's run in production, when it's run inside the servlet container. It has to use those APIs. I'm glad it does. But when it comes to testing, it's a little bit more challenging. So there is a way to test this. And the way that you do it is by using mock objects. So let's go look for in our unit tests here. It's not the integration test of the IT directory, but in this panel test, the unit test. Let's look at our appointment book server test. So I want to be able to interact with my servlet outside of a servlet container. And because of the way the servlet API is designed, this is possible, right? You can just instantiate a new servlet object. Luckily, it doesn't have to be running inside of a container, inside of a template container. And then, as long as I can figure out how I can invoke methods like doGet and doPost, and then interact with the objects that I provide them, I should be okay. So I hope that you had an opportunity, it was actually on the syllabus from last week, to watch the Testing with Mocks lecture. If you haven't, or if you did and you were like, this is crazy, please go back and do it again. It's one of the more advanced concepts in the course, but it's it's really powerful once you get to use it, because once you learn how to use it, because you can do things like write your own unit tests for your Java servlets. So now that's what I want to talk about now. I want to talk about how we can use the Mockito API to interact with our servlets. So I want to write a test that says initially I have no dictionary entries in the servlet, and the way I'm going to do this is by invoking the doGet method, and I'm going to I'm going to verify that no output is written to the request, because let me just go and do this again. I'm going to stop my server here to basically reset the dictionary. Oh, by the way, both the dictionary application and your application do not need to persist its data. It doesn't need to persist. The dictionary don't need to persist the appointment book to a file. Not a requirement for this project, which means that when the web browser, when the web container goes away, all the data is lost. I'm just going to restart it here. And when I'll just do it from here. So when I go and I load all of my appointments by hitting the appointments URL, it returns nothing. It is empty. It is blank. And that is the thing that I want to test for in this code. Okay, well, how do I do that? I basically want to say, great, create me a servlet, and the dictionary is initially empty, and I'm going to go and ask for all the appointments through the get method, and I'm going to verify that nothing is written to the HTTP response. I'm going to do that using mock objects. So recall from the lecture, there's this API called Mockito, and so this mock method comes from the Mockito library. And what it allows you to do is to take an interface and get like this magical instance of the interface that you can then program using special APIs to behave in the way that you want. Here we have some very simple mock objects. We have a mock HTTP request. We have a mock HTTP response. These are these mock objects that implement the interface. They are instances of HTTP servlet response or servlet request. And we're also going to do the same thing with print writer. This will give us this mock print writer because we don't need a real one. We just need one of these mock ones, and we'll see how this works in a moment here. So we create our mock objects, and then we train our mock objects, or I think of it as like programming the mock objects. We train the mock objects to behave in certain ways. So we say, hey, listen, mock response, when your get writer method is returned, so when response.get writer is returned, when response.get writer is invoked, then please return this mock print writer. Now, inside when we run this inside Jetty provides an implementation of HTTP servlet response, which has all sorts of real print writers and stuff like that. Here we don't need real objects, we want mock objects. Because what we're going to do is provide these mock objects to the real code. The real code will interact with them. It doesn't care that it's a mock. It's got an instance of an interface. It goes and calls the get writer method. Okay, and it returns some print writer. The fact that it's a mock print writer, the code under test doesn't care. Your get method doesn't care. Your test does, and we'll see how your test says that. That's exactly what the test does. It calls doGet. And it calls doGet with the request and response, these two mock objects that we create up here. Now, inside the body of doGet, right, is the same doGet that we debugged before the break. It uses get parameter to interact with the HTTP request. It uses get writer, or is it right here? Yeah, it's response.get writer to interact with the response. And when this unit test is run, it's provided with mock objects, but it doesn't care. As long as the object has behavior that it expects. For instance, when it calls get writer, it expects that there's a non-null print writer return, and that's exactly what we told it to do. It'll just do its thing. Which is super cool, because after we've run our code under test, then we can validate that the mock objects were interacted with in the way that we expect. So what we're going to do, we're going to say, hey, that print writer that I sent in, that mock print writer, well, I'm going to verify that its print line method was never invoked. Because we go and look at the behavior here, I guess if you drill down into the text dumper, you'll see that if the dictionary is empty, then print line is never invoked. Now, it will invoke flush, but we don't really care about that. But at least the test doesn't care about that. And so the test basically says, hey, listen, make sure that print line is never invoked, and make sure that the status that we get back on our response is SCOK, is 200. And again, that comes from this code right here, what we call set status. So this is like a completely new form of unit testing, where instead of working with real objects, we work with these mock objects. And we basically provide this facade that we pass into the real code. Real code doesn't care, it just interacts with it as it normally would. And then afterwards, we can say, hey, listen, we keep these mock objects keep track of how they've been interacted with. That's our job. They basically have bookkeeping, this magic bookkeeping that keeps track of what methods were called and how many times, what parameters were sent in. And then we can validate that the mock objects were interacted with as we expect. We're going to see some more of this, but before that, I want to pause for a question. Got one thumbs up. Okay. Okay. So that was a very simple test that interacts with our servlet using mock objects. Let's go into something more interesting. Let's write a test using mock objects that adds one word to the dictionary. So if you think about what the web browser or the client needs to do, or you go back and, actually what you really do is you go back to the assignment and you say, hey, I want to implement what happens when you interact with this URL, you give a post. And here it's like you got to provide all the required parameters. Okay. So now what I'm going to do is I'm going to create those mock objects. I'm going to create a mock request, and I'm going to train that mock object to behave as if I'm going to train that object to behave like my request that adds a particular word and definition, in this case, test word and test definition, to the server, to the dictionary application. How do I do that? Well, first I'm going to create my mock object again. I'm going to create my mock request. And we're going to use the when method, which we saw up there with the print writer. Right? We saw when before, when it's at the print writer. But now I'm going to say, hey, listen, when request.get parameter is invoked with word, the string word, then return my test word right here. Similarly, when get parameter is called with definition, I'm going to return my test definition word. The whole idea here is that this mock object behaves just like a real servlet's HTTP servlet request would when passed in with that data. Right? We're mocking that out. And here again, it's functionally equivalent. And so the code under test doesn't know the difference. It doesn't care. Right? All it knows is that when it asks for when it calls get parameter with word, yeah, it returns this string word. Okay, that's cool. It doesn't really mind. So, so that's how we mock out the request to provide those two parameters. Now we're going to mock out our response. And so we're going to have a mock object for our response. And in this case, there's going to be some more complex text written to the output. It's going to be that message that says, is that you define word as definition. And I want to capture all of that. And I probably could use the Mockito API to capture all that, but it might be kind of hard, it might be kind of awkward. So instead, what I'm going to do is I'm going to use a string writer to capture that. And the way I do that, and remember what a string writer is, right? It is an implementation of the writer class that writes, not to a file or to an output stream or something like that, but to a string in memory. So it's good for buffering up data and buffering up string data in memory. So I'm going to create a string writer. I'm going to create a print writer around that string writer. Then I'm going to train my mock object to say, well, listen, hey, when get writer is invoked on my response object, my mock response object, then I'm going to have it return that particular print writer, which ultimately writes to the string writer. I've mocked up my two objects. I've trained them to behave the way that I want, and now I call do post on them. Remember what do post does? It goes off and interrogates the request. Let me go find. Let me go find do post here real quick. Okay. Do post, remember what it does? It interrogates the word parameter. It interrogates the definition parameter, puts it in the dictionary, and prints out this defined word as, and then returns a COK. Well, I want to go validate that behavior. By doing the following. After I call do post, I'm going to get the string value from the string writer, and I'm going to assert that it contains this defined as word. Notice that this is Hamcrest API, right? This is Mockito. This is just like plain old Hamcrest, which you can do in a unit test because it's all Java code at the end of the day, right? So you can use Mockito just like as you would in project 23 and 4. Now, there's some other stuff I want to demonstrate, which is cool about Mockito. So we could just do what we did up here and verify that, yes, response.set status was set with SCOK. And like when you, when there's like one and only one value for this, that's a pretty easy thing to do. For the sake of demonstration, or I guess, or if you want to make multiple assertions against the value, you can use something in Mockito called an argument captor. More details are in the lecture. But basically, what this allows us to do is to, allows us to do is to capture a value that was invoked, that was sent to a method of a mocked out object. So we say verify response set status with, and then you say this argument captor dot capture. And the magic of, and through the magic of Mockito, when you then call get value on that status code, that will contain the value that was invoked, that was sent to the set status method. And then you use hamcrest again to assert that, yes, that value that came back from Mockito is equal to 200, is that status code that you have. And finally, as another example of how to make a code more testable, the servlet does have this method called getDefinition for a given word. Now, getDefinition is a method that I added to, well, maybe I added it in the get. I can't remember if where's this thing called? Usages is only used there. Fair enough. Here, all it does is it goes and calls get on the dictionary. And I've added this solely for the purpose of testing. Nothing else in the application really needs this. I want to keep my dictionary private and protected and stuff. So I'm only going to use it for testing purposes, but it's very handy because what this does is it makes sure that the side effect, that as a side effect of invoking doPost, that the word is actually defined the way I expect. So when I call, give me the definition on the servlet, when I ask the servlet, hey, by the way, what is your definition for that word? Yep, it's the definition that I expect. And this is how you write unit tests for servlets. Now, it's admittedly kind of awkward at first. And again, this is probably the most advanced thing that you've seen when it comes to unit testing inside the course. I'm sure it feels like I just started unit testing and now I'm using mock objects. This is crazy, but yeah, it is. I encourage you to dig into this though, because I think you'll find this very powerful. And it'll let you take a test-driven approach to this project, which is actually pretty huge when you think about it, right? Because there's a lot of moving pieces parts. And it takes a while to do things like restart your servlet every time you make a change to the servlet, and then rebuild your command line program and go back and forth and all that kind of stuff. More so than the other projects, taking a test-driven approach to this project will help you go faster, which will help you get it done faster, and you'll have unit tests to make sure that everything works. But it really requires that you learn enough about the Mockito API. But also requires that you really understand what's going on with the service, that you really understand the nature of the HTTP interface for this REST API, which is all part of the assignment, all what I hope that you do. So before we transition to one more topic before we end for tonight and go to pairing, any questions though about Mockito, about what we've done here? Okay. Now, the next thing that I'd like to look at is the command line program. So I think we walked through all of the stuff in the servlet. We've seen we've seen what doGet and doPost do. Oh, by the way, there is a doDelete. Actually, we'll see that in a moment. We've seen what doGet and doPost do, and we've seen how to test them in the servlet test. Let's take a look at the back to the picture. I like the map of the world. Let's take a look at what's happening on the left here in the project 5. Now, Project 5, we've seen the command line program at work here. Well, it takes some arguments and then interacts with the look at that. We got an arrest exception. Do you not print the error code, or it's not have it on screen? Oh, interesting. It doesn't print. It's a bug. It doesn't print the error code. Probably should. Sorry about that. Let's see here. Well, so then I'll just run this again. And now it's got a value. Yep, it prints it out. So this is Java code that is interacting with the REST API. Now, and the way it does this is the way it interacts. It uses an object called an appointment book REST client. So when I designed the project, my goal for this project is to give you experience working with the Servlet API and maybe writing some unit tests, some more advanced integration tests. And one of the things that I didn't think it would be very, very valuable for you to have to figure out is how to, in Java, go fetch a URL. Right? That to me was just like, there's plenty already to do this assignment. I thought I would make that easy. And so then I abstracted all of that in an appointment book REST client class. And I'll let you be the judge about whether or not that helps or hinders, but it's where you can start. So let's take a look at, let's look at the main method for the project. That is in the tests, project 4. Oh, shoot, is this project 4 or project 5? I forgot to update it. Sorry. Project 5. And you might not need to rename it. I think it'd be okay without it. Yeah, let's keep it project 4. So what does it do? Well, it parses the command line to get the name, the port, the word, and the definition. And after doing some error checking and parsing the port, then it does some interesting stuff. Then it goes and gets the appointment book REST client. And you create one of these given the host of the port. And the intent of this REST client is that it provides a fluent Java interface, set of methods with like parameters that make sense, over the REST API. Because here in the main method, we just want to deal with plain old Java objects, and we don't really. I want to keep the code like necessarily separated and have good separation of responsibilities. So I don't want the main method to have to deal with the intricacies of putting together URLs and populating all the data that gets posted to the server. I want to put that someplace else. I want to encapsulate that and really hide all those details from the client. Right? This makes it easier to work with. It abstracts things, which might be difficult to understand at times. I think it keeps things more simple. So let's take a look at what the main method does and how it interacts with the client to do various things. So it's read the host and the port and the word and the definition from the command line. And if a word wasn't specified, so if the only thing on the command line was a host and a port, then it goes off and it gets all of the word definition pairs by ultimately invoking HTTP GET. But this code doesn't care about that. All this code knows about is that it can call the get all dictionaries entry method of client. And what does that return? Well, that returns a map of strings, which is the dictionary. And so it gets that map, and now it's going to print it out using the pretty printer. And so then I wrote a silly little pretty printer that knows how to print a map to some writer, and it's going to print it out to that string writer, and then it's going to ultimately get the string there, and that's what gets printed out. Yeah, down here is something about that. Similarly, it's going to, if the definition is null, so if the word is not null and the definition is null, If the word is not null, but the definition is null, it will call get definition on the client and pass in a word. And here again, as we'll see shortly, get the implementation of get definition is the thing that pushes the right URL and goes off and makes the call. The main method doesn't care about that. All it knows is that this is going to then return it's going to return a string, I'm pretty sure. Yep, it's going to return a string, which is the definition for that word, and then it's going to call this format dictionary entry to make it free. Finally, if word is not null and definition is not null, then it's going to call add dictionary entry on the client, and then it's going to, and it doesn't return anything. And what it's then going to do is it's going to just print out, defined as words, those two words, as ultimately just printed out. Oh yeah, and by the way, it's going to handle any exceptions that occur. And I designed it this way on purpose, as to give you all an appreciation for separating out responsibilities. So here again, there's really no REST code here. Instead, all the REST code, all that responsibility is delegated to the appointment book REST client, Because here again, we want, well, there'll be a number of reasons, there'll be a couple of reasons, but we want the main method to really focus on the things and the concepts that it understands. What's the main method? Now let's look at the appointment REST client. Okay, this thing is a little bit more complex, not surprisingly, because it hides all of the details of interacting with the REST API. So there are some constants like appointment book and appointments that we use to create the URL. But then a lot of heavy lifting is done by this class that I wrote called HTTP Request Helper. And so then this thing, yep, it's one of my classes, and we'll see how to use it here shortly. First, we have the constructor for the first we have the constructor for the appointment book REST client that takes a host and a port. And what it does is it's going to initialize the HTTP request helper as a new HTTP request helper, and then HTTP request helper takes I guess one argument, which is the URL that is formatted. And here again, it's got the host and the port, and then the web app, which is appointment book and appointments. You don't need to change any of this code, actually, because that is the URL that's the reference there in the assignment. Now, just as a design note, I also have this. So this public constructor ends up calling this protected constructor for appointment book REST client, which just takes the HTTP request helper. And I'm pretty sure I have this. Here so that I can write I can mock it out. As a matter of fact, it wouldn't surprise me. Do I have? Yeah, I've got the appointment book REST client test here, and here I interact with it using a mock HTTP request helper. This allows me to write a true unit test for this REST client. Kind of neat. And we will. I don't think we're going to dive into that now. You can go explore that on your own. Okay, so I've created my appointment book REST client with the given host and port, and I've configured the HTTP request helper to go off and interact with this URL, the servlet URL. Now here's how I implement those methods that were called in main, like get all dictionary entries, right? So if we go back to main, recall that when neither a word nor when a word wasn't specified, when only the host and port were specified, what do? We call get all the dictionary entries. So now if we dive into that, what do we see? Well, the first thing it does is it calls this on the HTTP request helper, calls a method called get, and it provides it with an empty map. Now the get method, if you go and look at the implementation, you see it takes this map of parameters. These are the key value pairs that are passed in on the get URL. So like the word equals doe, and definition equals a deer, a female deer, right? Those are the key value pairs in that map. And well, if we went and looked at that implementation, ultimately what it does is it puts together the URL and goes and calls some Java code to fetch the URL. And it returns this object called response. This response, this is not unlike the evoked main API, in that, okay, this is an object that represents the HTTP response, that represents the payload that was returned by the servlet. It makes sure that the response has a status which is something other than HTTP OK. And so it's just a little helper method. So you get this REST exception thrown if it returns anything except a code 200. And then, so if it gets this far, it means that the request was successful. It returned a 200 OK. And so what we're going to do, well, we are going to get the content from the response, and this is the string that was written back to the HTTP server response, to that print writer. It gets that string. Remember, this is on the client side, right? It's gone over the internet. It's gone over the socket from the server. It's now here at the client. We have that payload that was returned, and we are then going to parse it using our text parser. So this is a string. We're going to wrap a string reader around that and send it to our text parser. And our text parser in this case returns a map of string to strings. It knows how to parse that. And that's all you're doing. And here again, this is like 4 lines of code that do a lot, but this is then provided in a nice fluent Java API where the main method doesn't need to know all these details about calling HTTP GET and taking all these things using the text parser. All it knows is that it'll return a map of strings that represents all the dictionary entries. Import and abstract. So this performs an HTTP GET with no key value pairs to get all of the dictionary entries. Similarly, get definition provides a word, and it then makes a query of the REST API to get it makes a query of it does a HTTP GET of the REST API with a map of key value pairs for string word, which again appears on the URL. So we're basically we are saying saying word equals me, right? We are crafting that URL in this Java code by putting in a map of key value pairs where the first the key is word and then the value is, well, whatever that word parameter that's passed in here. And again, this goes off, crafts the URL, forms the HTTP GET, gets the payload, includes that payload in the response payload in the response object. We make sure that we got a an HTTP 200, and then we go get the content again. And just like up above, we parse it with a text parser. And in this case, we're not returning the map. We're just going and getting the map from the parse method, and we'll call get on the map for that word. And that returns the one word. Again, providing a fluent Java API over the REST API. The last thing that we do, we have the add dictionary entry method. Remember, that was invoked when all 4 parameters were passed on the command line. And this is the thing that creates dictionary entry between a word and a definition. This time, we're going to call the post to my URL method, which is basically a wrapper around http.post. We created it so that it's easy to test. And what we pass in is a map, again, of those key value pairs. It's got 2 key value pairs. The first one is word, and the second one is definition and the definition. And that is ultimately, through the HTTP post method, that is ultimately passed back to the servlet, gets routed to the doPost method, does all the stuff on the server side, and then returns the result and the response. And here, we're not going to pay attention to the payload in the response, apparently, and we're just going to make sure that it doesn't return anything. It doesn't return a non-200 URL. So the lesson in this code is that we have divided up things. between the code that works with the code that works with HTTP and then the code that works with Maven. So we now have these client-side objects, these client-side classes, things like the main method and things like this appointment book REST client. And now we can write tests for them. So we could mock this stuff out, but you know what? This is like real code, and I would like to be able to exercise it in a real environment. And Maven lets you do this really easily. Because as you may recall, when you run the integration test under Maven, the Maven project will start up Jetty and deploy your code to it. And so then our integration tests are finding out true integration tests where we can have a test that creates a real appointment book REST client that talks to a real REST API and does things like, again, it verifies that, yes, an empty server contains no dictionary entries. Or that, hey, defining, one word actually defines it. And we do use this by exercising the REST API client, the appointment book REST client. And so like we call add dictionary and add the 2 words. And then we then call get dictionary to verify that, yes, the definition that we received back was what we expected. And so now let's see here. I've got my server running. So now if I run this, it passes because it went and called the server. But then stop the server. Oops, stop the server. And I run it again. The test fails, saying connection refused, because yes, it attempted to communicate with a server on localhost 8080, and it didn't run. So I'm going to run it. So I'm going to start the server again. Make sure it starts up. Yep. Now when I run it, it passes. And now I run all of the tests. Out of this. Nice. Yep, they all passed. And just a couple of things to note. I use a special annotation that runs the test in a certain order because the first one is the thing that removes all the dictionary entries. I suppose I could probably use a before class on that too, but anyway. And so these tests do have. There's no test 3 anymore. They do depend on each other. Oh yeah, this is kind of an interesting one. This one asserts that if you attempt to add an empty string, you get a REST exception, and then you can get some information about it there. So the whole idea here is that I'm showing you various ways to test this project. We saw that you can write unit tests for these things using Mockito, which is cool and fast. Makes it really easy to go quickly with this. And you can also write end-to-end tests with the integration tests. And as I said, these are true integration tests because they're much more complex than the unit tests because they work with the real running code running inside of Servlet. And I'm just going to note it. I'm not going into detail. You can also, so this project for IT uses our old friend invoke main to run the main method with an actual with an actual server running. So I can run these now that my server is running. They'll go and interact with them, and yep, everything passes. And now if I go and I go and look to see what's inside that server, word and definition in all caps because that's what was. Let's see here. Where did I do that? Oh yeah, here's like word, and here's word and definition. Yep, here's where I invoke main and put that stuff in there. So yeah, so test-driven development is possible. And of course, when this project's required, we have the test coverage requirement for the project. But it's possible with web applications. Okay. that was everything I had about the project. Let's see here, just to reiterate, it is due March 6th. Just want to double check to make sure that's the right date. Yep, project 5 is due March 6th. I know there was a lot, and it was some new concepts, and it was probably stuff went by kind of fast. But any questions that I can answer right now? Seeing somebody that the recipe project is pretty challenging at first, but ends up being a lot of fun because you're working with two programs at the same time and you're trying to get everything to work. So I know you're probably going to start on it right away, and so we can come back to it. Let's see here, maybe next week or the week after that, if there's sort of more detailed questions. But please feel free to get started now. Actually, make sure at least you can create the project to make sure that everything's working. It ought to work for you, but don't want to discover that too late. Okay. So it's 7:30. The only thing left in class is the final pair programming. And actually, just show of hands. So if you could just raise your hand or somehow indicate who wants to participate in the remote pairing. Okay, got one, and then two. Okay, just one pair, which will be fine. Okay, oh, you guys also, okay. Okay, awesome, okay. Oh, good, we got a bunch of people. So maybe we'll have we'll have a couple of pairs then. That's awesome. Okay, well then, let's take a break though. I think we need a breather. Let's take 10. Yeah, we'll come back after 7:40. I'll introduce the Kata. We will use Zoom breakout rooms. And if you're not planning on pairing, please leave. Go stay warm. Go learn about Mockito or something like that, or go to bed. Those folks we'll see next week. Everybody else who's sticking around for pairing, we'll see you in another 10 minutes or so. Hey everybody, welcome back. Okay, now we're doing some pair programming for the rest of the class. This is the third time we've done it, so I hope everybody's pretty clear on what needs to be done. I guess first of all, tonight's kata is called lags, and it's a link to off of the course website. I also put a post, I put a link to it in a post on Slack. I added a lags set of projects in the Kata's repository. So I believe everybody's got a checkout of that. So please open that up in your IntelliJ, pull down the latest changes, make sure that you've got this lags directory, this lags parent with a number of pairs. I'll be opening the breakout rooms. I created 3 breakout rooms. I see 6 people, and so I would like to have 3 pairs, if at all possible. And let me just quick talk about this Kata. So I don't know what you've done in your algorithms courses or data structures or something in terms of scheduling and overlapping things, but that's what this Kata is all about. You've got a pretend little airline that's got one plane, and it only goes between 2 sites. Well, actually, maybe it goes between different sites, and anyway, the whole idea is that you got one plane, and various customers call in and they say, "Hey, I want to travel on the plane at this time, and I'll pay you this much for it." And then someone's like, "I want to travel between these 2 times, and I'll pay you this much for it." And so you've got all these bids, I guess, for your time. But knowing that you can't be in 2 places at once and you've got one plane, you need to then choose the bids, accept the bids that will return you the most money. And so the way it comes in is in this text file or in this data format. So you've got, I don't know, there's a flight number or something like that. And then it goes from time 0, hour 0 to hour 5, and they'll pay you $10 for it. Similarly, this one goes from 3 to 7, they'll pay you 14, 5 to 9, pay you 7, 6 to 9, pay you 8. And the job of the Kata is to write some scheduling software or to write some software to then accept the bids that net you the most money. In this case, it would be flying first from 0 to 5 for $10, and then 6 to 9 for 8 for a total of $18. But your code needs to be smart enough to decide, oh, should I go for this 5 to 9 for 7, knowing that I couldn't do the 6 to 9 for 8? No, it should really pick the first one and the last one. That's ultimately what you need to do. I encourage you to not focus so much on something like parsing this file or reading this from the command line. Instead, just creating, inputting this data into some object that then does the calculation. I think that's the interesting part of the Kata. I hope everybody's back. Let's see here. So, any questions about the Kata? Sort of what we were supposed to do before we get started. So I will open the breakout rooms now. I'm going to have my timer going here in the classroom. I'll also check in with each room just to make sure everybody's getting off the ground okay. But what I recommend, one of our big learnings from the first 2 pair programming is that students realized, sort of like after the second round, that we should have done some planning. So what I'm going to do is I'm going to start out with 10 minutes of just planning. So, other than sort of updating your environment and maybe putting your name into the pom.xml if you want, just talk about this. Maybe sketch some things out or take some notes. Brainstorm some test cases. Remember, we're on like the second, third week that we did the given, when, then exercise. If something like that, I think would be good to hear. Good to do here. Great. We'll take the first 10 minutes doing that, and then we'll go into the 10-minute blocks of 7 minutes of coding, 2 minutes of reflection, 1 minute of switching, and then go to the next person. So anyway, that'll be the schedule for tonight. We'll do that until 9 o'clock, and then I do want a quick debriefing because I'm really interested to hear about your experiences working in remote pairing as opposed to the in-person pairing. So everybody all clear on the plan for the rest of the evening? Awesome. I will open up all the rooms, and you can go to whichever room that you want. So go find a partner, or go meet someone for the first time. So Cameron, the Maven verify shouldn't fail. It should be okay if you're using main. I can go double check on that. Kata's winner 2024. Yeah, it looks like it's okay. So I'm not sure what's going on there. So if you run into problems, I'll just hop into your room.
Okay, thanks.
Yep. Okay, hey, we're back. So I am really curious to hear about your experiences tonight working remotely. We had all the pairing being remote, and how that differed from your experiences here in the classroom. So I'm going to ask each room just do a quick report out, if you don't mind coming off mute, and just talking about how it compared and contrast. What was the same? What was different? Were there any differences that made it different? What was it like? So starting with room 1, that was Aiden and Natalie. What did you think? How did it work tonight, and how did it compare to other nights?
So I think being on Zoom didn't like play that much of a role for us, but I do think with this time, like, because we worked together last time too, we were able to like agree on ideas sooner, and then we got our like the thing done. So I think it went pretty smooth.
Nice. Natalie, anything to add or amplify?
I actually thought Zoom worked a lot better,
Ooh,
because it's really hard to read someone's laptop screen when you're sitting next to them because those things have like side looking protection. Um, so sharing screen is actually, I think, a lot easier.
Awesome. Great observations. Sorry, something else?
No, I do think this project went better than the last one. We were not held up by we figured out a plan, and then we did our plan, and we even had time to test our plan some. So
Sweet. Excellent. That's all great to hear. Thanks. Room two, it was Amanda and Katie. What were your experiences like, and how did they compare to your in-person pair programming?
One thing that we were able to do through remote that we weren't able to, or I didn't, it would have been more challenging to do in person, is while one of us was coding, the other one was like looking up something, like the specific imports for the tests. And so like with the Zoom meeting, we can just paste the those imports in the chat, and then like the other person can copy them.
Awesome observations. Katie, anything to add?
Not really. I can't really think of much to add.
Okay, great. Cool. In room three, Cameron and Nora, what were your experiences like tonight?
Yeah, we tried using the whiteboard functionality to sort of map out what we were doing. That kind of worked because when we wanted to start the coding, we kind of had to get rid of the whiteboard. So
yeah, right.
that was kind of annoying, but it was really nice to just be able to see exactly where Cameron was typing, and it's very easy to see.
Yeah, I was gonna say the same thing. I thought Zoom kind of limited us, that we could only have one thing shared at a time. I know when I did it in person, like we were writing on paper and it was like more obvious. We had a paper in front of us and we could both look at it whenever we wanted to. But with Zoom, we always had to close the whiteboard. It was just annoying. So there's that.
Interesting. Fascinating. Three very different experiences. Well, thank you all for sharing them. I'm glad everybody got to experience, or many of you got to experience, both in person and remote pairing. As you can see, there was different experiences and different kinds of learning. Great. Well, and that's everything for tonight. So let's see here. Don't forget that between now and next week, if you haven't already, please fill out your reflection. This is how you're graded on your pairing. I'm really curious to hear overall, and that you've had 2 or more experiences doing it. What do you think? And where do you think it would be effective, and where do you think pairing would be ineffective? Next week, we've got a really exciting week. We're going to be talking about refactoring. And actually, this is brand new content for me. So if it seems a little more chaotic than usual, that's because it is, because I've never done this before. And the way we're going to approach it is, well, I'm still working on the slides. So I'll get a screencast out by like Monday morning. And so please make sure to set aside some time early next week to review the screencast all about refactoring. And then what we're going to do in class is we're going to do a refactoring kata, all of us together. Not exactly mob programming. We're going to figure this out together, but we're going to look at some code, which I looked at the code. It's kind of gnarly. It's kind of ugly. And we're going to figure out how to make it better. We're going to figure out how to make it more testable, more readable, more extensible, while still solving the problem it was meant to solve. I think there's some bugs in there, and we're going to fix those too. So a really kind of cool and unique experience. I encourage people to come to the classroom if they're up for doing so, but we will have people remote because it will be interactive. We'll be doing some, small group discussions and then large group refactoring as we learn how to apply these techniques to improving our code, making it more clean, more readable, and more extensible. So I'm looking forward to that. Hope to see many of you in the classroom. Hope to see all of you in some form next week. In the meantime, I hope it's a good one. Please get started on the next round of projects. Because as you saw, Project 5 was assigned tonight, and there's lots of stuff to do there. So all good things. I hope you have a great week, and I'll see you next time. Good night, everybody.